The initial illustration presents a scenario where, despite the absence of malicious intent, the undesirable outcome of a broken lamp transpired. This underscores a critical distinction between intent and consequence. While intent doesn't necessarily excuse the result, it furnishes a framework for comprehending it. Turning to code interpretation, it's paramount to consider both the intent and the precise language of the rule. Intent can elucidate the rule's underlying purpose and setting, while the specific wording articulates the exact stipulations. However, should a discrepancy arise between the two, the wording generally assumes priority. Comprehending the intent behind rules proves valuable for several reasons. Firstly, historical context. Intent can shed light on the circumstances and concerns that motivated the creation of a specific rule. Secondly, interpretation guidance. When the rule's wording is ambiguous or susceptible to varied interpretations, grasping the intent can aid in the interpretation process. Thirdly, education and compliance. Comprehending intent empowers stakeholders to appreciate the rule's purpose and significance, thereby encouraging adherence and diminishing the potential for infractions. Lastly, balance between intent and wording. The interplay between intent and wording in code interpretation mandates a judicious approach. While intent offers valuable context, it cannot supersede the explicit mandates of the code. By meticulously evaluating both elements, code enforcers and stakeholders can render well-informed decisions, ensuring that the rule's intent is mirrored in its implementation. The balance between intent and the explicit wording of a rule is a cornerstone of proper application. While the wording provides the direct and enforceable requirements, understanding the intent behind the rule adds a layer of comprehension that is crucial for effective implementation and avoiding unintended consequences. Imagine a scenario involving electrical wiring. The code might state that all splices must be made inside an approved junction box. The intent behind this rule is to contain any potential arcing or fire hazards, protecting the building and its occupants. If someone were to interpret the rule very literally, they might argue that as long as the splice is physically inside a junction box, the rule is satisfied, even if the box is not properly closed or secured. However, understanding the intent reveals that the goal is complete containment of any electrical mishap. This understanding would lead to ensuring the junction box is not only present, but also properly installed and closed. To delve deeper, let's consider instances where strict adherence to the wording alone could lead to outcomes that contradict the intended safety measures. For example, suppose a code states that all outdoor receptacles must have weather-resistant covers. The intent is to prevent water from entering the electrical system, which could cause a short circuit or electrocution. If one were to simply install a weather-resistant cover that doesn't properly seal because it is damaged or improperly sized, they might technically comply with the wording of the rule. However, the intent of keeping water out is not achieved. A trained electrician who understands the intent would recognize the faulty cover and replace it with one that provides a proper seal. Further, the understanding of intent becomes invaluable when dealing with older codes or situations where the wording may not perfectly address current technologies or practices. Consider a rule that mandates specific clearances around electrical panels to ensure accessibility for maintenance and emergency shutdowns. The intent is to provide enough space for workers to safely access and operate the equipment. If a new type of panel is installed that requires more space for safe operation than what the original code specifies, blindly following the old wording could create a hazardous situation. By understanding the intent, inspectors and installers can apply the rule in a way that meets the original safety goals, even if it means exceeding the literal requirements of the wording. Intent also plays a vital role in resolving ambiguities within a code. Sometimes the wording of a rule can be open to multiple interpretations. In these cases, understanding the intent can provide clarity. Suppose a code states that all wiring must be adequately supported. The wording is vague. What constitutes adequate support? The intent, in this case, is to prevent strain on the connections and to ensure the wiring doesn't become a hazard due to sagging or physical damage. Armed with this understanding, an electrician can make a judgment based on factors like the type of wire, the span between supports, and the environmental conditions to provide sufficient support that aligns with the intended safety goals. Moreover, knowing the intent behind a code can foster a more proactive approach to safety. Instead of merely complying with the minimum requirements, individuals who understand the intent are more likely to identify potential hazards and implement solutions that go above and beyond what is strictly mandated. For instance, a code might require ground fault circuit interrupter or GFCI protection in bathrooms. The intent is to prevent electrocution in wet environments. Someone who understands this intent might choose to install GFCI protection in other areas where water is present, such as kitchens or laundry rooms, even if it's not explicitly required by the code. This proactive approach demonstrates a commitment to safety that goes beyond simple compliance. In addition to practical applications, understanding intent can also promote better communication and collaboration among different stakeholders, such as designers, installers, inspectors, and building owners. When everyone understands the why behind a rule, it's easier to have constructive conversations about how to best implement it in specific situations. For example, if a designer proposes an alternative wiring method, being able to articulate how the alternative meets the intent of the code can facilitate a smoother approval process with the inspector. In conclusion, while the specific wording of a code provides the enforceable requirements, understanding the intent is essential for effective implementation, resolving ambiguities, promoting proactive safety, and fostering better communication. A balanced approach that considers both the what and the why is the key to ensuring that codes are applied in a way that achieves their intended goals of safety and functionality. Consider another example relating to electrical grounding. The code mandates that all metallic enclosures containing electrical conductors must be grounded. The intent behind this rule is to provide a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or fuse and quickly de-energizing the circuit in the event of a ground fault. This minimizes the risk of electric shock and fire. Now, suppose an electrician encounters a situation where they are installing a new piece of equipment in an old building. The existing grounding system is inadequate, perhaps due to corrosion or undersized conductors. If the electrician simply connects the new equipment to the existing grounding system without addressing the underlying problem, they may technically comply with the wording of the rule. However, the intent of providing a low impedance path for fault current is not achieved. A knowledgeable electrician who understands the intent would recognize the inadequacy of the existing grounding system and take steps to upgrade it, ensuring that the new equipment is properly grounded and protected. Another example can be found in the area of fire safety. Building codes require the installation of fire-rated doors in certain locations, such as between a garage and a living space. The intent is to prevent the spread of fire from the garage into the house, providing occupants with more time to escape. Now, imagine a homeowner who installs a fire-rated door but then props it open with a door stop for convenience. They have technically complied with the wording of the rule by installing the door, but they have completely undermined the intent of preventing fire spread. A fire inspector who understands the intent would recognize this violation and require the homeowner to keep the door closed. Moreover, understanding intent is crucial when dealing with new technologies or innovative designs that may not be explicitly covered by existing codes. For instance, consider the growing use of solar panels on residential rooftops. Codes may specify requirements for wiring methods, disconnects, and overcurrent protection, but they may not address all of the unique challenges associated with solar installations, such as the potential for arc faults or the need for rapid shutdown capabilities. In these situations, understanding the intent of the code can help guide the design and installation process, ensuring that the solar system is safe and reliable, even if it means going beyond the literal requirements of the code. It also allows for a flexible approach. Consider the evolution of lighting technology. Traditional codes often specified the types of lighting fixtures and the maximum wattage allowed in certain areas. The intent was to ensure adequate illumination while preventing overheating and energy waste. However, with the advent of energy-efficient LED lighting, these traditional rules may no longer be appropriate. LED fixtures produce more light with less energy, so a strict interpretation of the old rules could actually limit the amount of light available in a space. By understanding the intent of providing adequate illumination, inspectors and designers can allow for the use of LED fixtures that exceed the wattage limits, as long as the overall lighting levels are appropriate and the fixtures are installed safely. Let's examine the topic of accessibility. The Americans with Disabilities Act, or ADA, sets standards for accessible design in buildings. These standards specify requirements for things like ramp slopes, door widths, and restroom layouts. The intent is to ensure that people with disabilities have equal access to buildings and facilities. Now, suppose an architect is designing a renovation of an existing building. Due to structural constraints, it may not be possible to fully comply with all of the ADA standards. In this situation, understanding the intent of the ADA can help the architect find creative solutions that provide the greatest possible degree of accessibility, even if it means deviating slightly from the literal requirements of the standards. This might involve using assistive technology, providing alternative routes, or offering personalized assistance. Intent can also apply to emergency systems. Codes require the installation of emergency lighting and exit signs in buildings. The intent is to ensure that occupants can safely evacuate the building in the event of a power outage or other emergency. Now, imagine a building owner who installs the required emergency lighting and exit signs but fails to maintain them properly. The batteries in the emergency lights are dead and the exit signs are burned out. In this situation, the building owner has technically complied with the wording of the rule by installing the equipment, but they have completely undermined the intent of providing a safe evacuation path. A fire marshal who understands the intent would recognize this violation and require the building owner to repair or replace the defective equipment. Another area where intent is important is in the interpretation of product listings and labeling. Electrical equipment must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or AL. The intent is to ensure that the equipment has been tested and found to be safe for its intended use. However, the listing and labeling can be complex and sometimes difficult to understand. An electrician who understands the intent of product listings will carefully review the label to ensure that the equipment is being used in accordance with its intended purpose and within its rated capacity. They will also be aware of any limitations or restrictions that are specified in the label. Consider the design of electrical systems. Codes require that electrical systems be designed and installed in a neat and workmanlike manner. The intent is to ensure that the system is safe, reliable, and easy to maintain. However, the definition of neat and workmanlike can be subjective. An electrician who understands the intent will take pride in their work and strive to create a system that is not only functional but also aesthetically pleasing. They will carefully route and support the wiring, properly terminate connections, and label all components clearly. The interpretation of the National Electrical Code, or NEC, relies on the balance between the literal wording of the code and the intent behind it. Let's analyze specific NEC sections to illustrate this. Take NEC section 110.3 B, which deals with the installation and use of listed or labeled equipment. The wording states that listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. The intent here is to ensure that equipment is used safely and effectively as determined by the testing laboratory. Simply installing a listed device isn't enough, it must be done according to the manufacturer's specifications. Consider NEC section 250.4 A1, which addresses grounding of electrical systems. This section requires that grounded systems be connected to earth in a manner that limits the voltage to ground in the electrical system. The intent is to provide a stable reference point for the electrical system and to minimize the risk of electric shock. The literal act of connecting to ground is only part of the equation. The connection must effectively limit voltage. Now consider NEC section 300.4, which covers protection against physical damage. This section requires that wiring be protected from physical damage during and after installation. The intent is to prevent damage to the insulation and conductors, which could lead to shorts, ground faults, and fires. The type of protection required will vary depending on the location and the type of wiring. For example, wiring run through a wall cavity may need to be protected by a metal sleeve or a nail plate. In NEC section 310.15, which deals with ampacity of conductors, the code provides tables that list the allowable ampacity of different sizes of conductors. The intent is to prevent conductors from overheating, which could damage the insulation and cause a fire. The ampacity of a conductor depends on factors such as its size, insulation type, and the ambient temperature. Understanding the intent allows for adjustments based on specific conditions as detailed in the code. Consider NEC section 400.8, which restricts the use of flexible cords and cables. This section prohibits the use of flexible cords as a substitute for the fixed wiring of a structure. The intent is to prevent the overuse and misuse of flexible cords, which are more susceptible to damage than fixed wiring. Flexible cords are only intended for temporary connections and for powering portable equipment. In NEC section 408.36, which deals with overcurrent protection, the code requires that each ungrounded conductor be protected by an overcurrent device at the point where it receives its supply. The intent is to protect the conductors from overloads and short circuits, which could cause them to overheat and start a fire. The size of the overcurrent device must be matched to the ampacity of the conductor. NEC section 430.52 dictates the motor overcurrent protection. It specifies the maximum size of the overcurrent protection device for motor circuits. The intent is to protect the motor and its associated wiring from overloads and short circuits, while still allowing the motor to start and run normally. The size of the overcurrent device depends on the type of motor, its horsepower rating, and its starting current. Then there is NEC section 450.3, which covers the installation of transformers. This section specifies requirements for transformer overcurrent protection, ventilation, and clearances. The intent is to prevent transformer failures which could lead to fires, explosions, and other hazards. Transformers must be installed in a well-ventilated area to prevent overheating. Consider NEC section 500.5, which classifies hazardous locations. The code classifies hazardous locations based on the type and amount of flammable gases, vapors, or dusts that may be present. The intent is to ensure that electrical equipment installed in these locations is designed and installed in a way that will not ignite the flammable substances. Equipment used in hazardous locations must be specifically listed and labeled for that purpose. Finally, NEC section 517.13 covers healthcare facilities. This section specifies requirements for electrical systems in healthcare facilities to protect patients and staff from electrical shock hazards. The intent is to provide a safe and reliable electrical system that will not compromise patient care. Healthcare facilities must have a redundant power supply and equipotential grounding systems. These examples show that successful code application requires a balance of the wording and the intent. The code is not a list of checkboxes, but it is a framework of safety.